Good afternoon, all of you. So yesterday we discussed about different types of polygons and convex. Out of that, we discussed convex polygon, concave polygon, and regular polygon, irregular polygon, like that. Related to that concept, some problems are there in the exercise question, exercise 3.1. Okay, so here given some figures. The given question is this: classify each of them on the basis of the following. Okay, we want to classify each figures. Some instruction is given. Then first question A is, which is simple curves. Out of these figures, which figures are simple curve? So simple curve we know there will not be no cross section. So which figures will be simple? What about the first one? Is it simple or not? Yes, it is simple curve. 2 also simple curve. It is not simple because 2 figures are there. 1, 2, 5, 6, 7. This full including simple curves. And these are not simple curve. Next, question B. Simple closed curve. Which are simple closed curve? All these are simple closed. Here 1, 2, 5, 6, 7. These 5 figures are simple closed curve. Next, C is polygon. Out of these figures, which are polygons? Polygons we know. A simple closed curve made up of only line segments. So first, what about the first one? All are line segments, and it is also a simple closed. So it is a polygon. Question 2. Figure 2 also polygon. 3 is not polygon because it is not simple. D also not simple curve. 5. What about 5? Is it polygon? No, because it is not made up of line segment. It is curve. D, B, 6 also curve, 7 also curve. So only polygons are 1 and 2. Next, D, convex polygon. Out of these 2 polygons, which is convex polygon? Only 2. Okay. Next, concave polygon. Concave polygon, this one, that is when we draw any diagonals, that will be exterior part of that figure. So we can draw one diagonal from here to here. So it is our exterior part of that figure. So it is concave polygon. When we draw the diagonals of these, we will get or will be on the interior part of that figure. So next question. Question 2. How many diagonals does each of the following figures? First question is given a convex quadrilateral. A convex quadrilateral will be how many diagonals will be there? A quadrilateral, any shapes of quadrilateral you can draw. Then how many diagonals will be there for a quadrilateral? It is line segment drawing from one vertex to non-consecutive vertex. So 1 and we will get another one as. So 2 diagonals only we can draw for a convex quadrilateral. A regular hexagon, how many diagonals will be there? A regular hexagon. Regular hexagon we know what is regular, which is equilateral and equiangular. Then that hexagons are called a regular hexagon. So when we draw, it should be regular. Okay. Now how 1, 2, 3, 4, 5, 6. Okay. So we can draw the diagonals. One diagonal we can draw from here. 1, 2, 3. Okay. Then from here 4, 5, 6. Okay. Then 7, 8. Then from here also we can draw. Total how many diagonals we can draw? 9 diagonals we can draw in the case of a regular hexagon. You just draw a regular hexagon and draw that much possible diagonals you can draw. Then last when you count it will be 9. one, a triangle. How many diagonals we can draw in a triangle? Can you draw any diagonals from a triangle? So only 3 vertices are there. We can't draw. All vertices are consecutive. This vertex A, B, C. No non-consecutive vertices are there. When we consider the vertex A, B also a consecutive vertex and C also another consecutive vertices of A. We take any vertex B also. When we consider the vertex B, A and C are the consecutive vertices of B. Just like when we consider the vertex C, the vertices A and B both are the consecutive vertices of C. So we can't draw any diagonals in a triangle. Okay, clear? Now, next we want to study one important property of a quadrilateral that we discussed in the case of a triangle. This angle-sum property of a triangle. Angle-sum property of a triangle we discussed earlier. Just like here we want to discuss angle-sum property of quadrilateral. When we discuss angle-sum property of a triangle, what is the sum of the 3 angles in a triangle? That we already learned. What is the sum of the 3 angles? Angle 1, angle 2, angle 3. Its sum always will be 180. Angle 1 plus angle 2 plus angle 3, it will be 180 degree. And when we consider the quadrilateral, when we draw any quadrilateral and we want to prove the 4 angles of this quadrilateral. The sum of the 4 angles of this quadrilateral is 360. That we want to prove. Then using this property of angle sum property of triangle, we can prove the angle sum of a quadrilateral is 360. For that, first we draw a quadrilateral and divide that quadrilateral, and otherwise we draw a diagonal of this quadrilateral. I draw one diagonal of this quadrilateral. After drawing that diagonal, we got 2 triangles. Okay, so that 2 triangles. Then we know what will be the angle sum of these 3 angles. These 3 angles, that is, I name this angle. This is 1, this angle 2, this angle 3. This is 4, this 5, this angle is 6. Okay, so what will be the angle sum of angle 1 plus angle 2 plus angle 5? That we know that will be 180 degree because it is a triangle. Just like what will be the sum of angle 3 plus angle 4 plus angle 6, that also will be 180 degree. Now when we give the name of this is angle 1. Just to give the name of that quadrilateral A, B, C, D. Okay. Now angle 1 plus angle 2 plus angle 5. Now when we add this both full side, angle 1 plus angle 2 plus angle 5 plus angle 3 plus angle 4 plus angle 6, that will be equal to what? 180 plus 180. Okay, because we got the sum of these 3 angles 180 and sum of these 3 angles 180. And when we add these 6 angles, what will be their sum? 180 plus 180. So we can take angle 1, we can write it as angle 1 itself. This we added. Next, angle 2 and angle 3. These 2 angles we take, angle 2 and angle 3. So angle 2 plus angle 3. Next we add angle 4 plus. Now angle 5 and angle 6 together. Angle 5 plus angle 6, that is, we just add this LHS side full. When we add the LHS full, the result will be the sum of this RHS 180 plus 180. So that will be equal to 360 degree. Now angle 1. Now angle 2 plus angle 3, that we know. What is that angle 2 plus angle 3? That will be angle 4 angle D. So angle 1 plus, we can name this common. Total of this angle 2 and angle 3, we can take it as angle B plus angle 4 also, we can write it as 4. Next, angle 5 plus angle 6. What is the sum of these two angles? It will be angle D. So angle D, that will be equal to 360 degree. Now we know angle 1, that we can represent as angle A, okay, plus angle B plus angle 4, that we can take it as angle C plus angle D, that we got 360 degree. Now what we proved? The sum of the four angles of a quadrilateral is 360 degree. So, okay, that is we proved by using the property of sum of the angles, sum property of the triangles. We draw a diagonal of the quadrilaterals and divide. Then after drawing the diagonals, we will get two triangles, and when we add the sum of these sum of the angles of all these, we will get, first we add the sum of the first triangle, sum of the angles of the first triangle, that will be 180. Then add the sum of the angles of the second triangle, that also 180. Then add this full left side full, add angle 1 plus angle 2 plus angle 5 plus angle 3 plus angle 4 plus angle 6, that will be equal to 180 plus 180. Using that, we will get last angle A plus angle B plus angle C plus angle D, that will be equal to 360 degree. Another way also there for the proof of that sum of the angles of a quadrilateral is 360 degree, that we can do by doing one activity. Take any two quadrilaterals, that I will show as another class. Okay, thank you.